This narrated PowerPoint is going to be focusing on Wien's law. Wien's law is an important formula that relates the wavelength at which an object radiates most strongly to its surface temperature. Here is Wien's law right here. Let's look at the important parts. On the left-hand side, we have this lambda max. That's the wavelength of maximum emission. That is the wavelength at which the object emits most strongly or most intensely. On the left-hand side, we have this number, which is a constant. This is going to convert centimeters into degrees Kelvin for us. And in the denominator here, we have the temperature in degrees Kelvin. So there's only two ways that you could have a Wien's law problem. In one case, you would be given the wavelength and you would have to solve for the temperature. In the other, you'd be given the temperature and solve for the wavelength. So let's look at this problem. It says here, what is the surface temperature of an object in space that emits most strongly at 1 millimeter or 0.1 centimeters? So we can identify this as a Wien's law problem because we have the surface temperature mentioned and a wavelength. Now in this case, we are given the wavelength and we need to solve for the surface temperature. So what we need to do is we need to isolate the temperature by itself. We need to cross multiply and solve for T. Now if you've been going through these videos, we've done a lot of cross multiplying. So let's just see if you can do it yourself and get to the right answer. So if we solve this for temperature, the temperature is going to be equal to 0.29 centimeters Kelvin divided by lambda max. Right? So the Kelvin on one side for the temperature will match the Kelvin over here in this constant. The centimeter here has to match a centimeter in lambda max. Now notice that we're given lambda max in two different units. We're given it in millimeters and we're given it in centimeters. In order to get the centimeters to cancel, we're going to have to use this value. So I'm going to take the 0.29. I'm going to divide it by 0.1. Again, the centimeters cancel, leaving me with Kelvin. And if you grab your calculator, you end up with 0.29 Kelvin. That's only 3 degrees above absolute zero, which is incredibly cold.